Okay, so let us have this single phase two-wire line. No, we'll make use of the previously derived VKI equation. Okay, so in this case, we'll consider two conductors, X and Y. So that will be our K and Y. Okay, and for the M, it's either X or Y. So depende which conductor charge are we referring to, no? Okay, so let's start off with V, your XY as KI is equal to 1 all over 2 pi permittivity. Okay, now we'll start off the summation. Okay, start off with X conductor, so QX. Okay, so technically it's QX. Okay, but because of the conservation of charge, we are now having QY, okay, the charge on conductor Y, that is equal quantity of that the charge in conductor X. Parang sort of QX is equal to QY, but equal in quantity, yes, but the direction is different. No, the charge dun sa QX is positive, whereas the other charge QY is negative, but of the same quantity. Okay, equal quantity siya. One positive and the other one is negative charge. Okay, so for QX and QY, we'll be using Q. Okay, so in this case, yung QM natin for ours first is QM. We'll just make use of Q. Okay, kasi same charge naman siya. Okay, so Q ln of DIM. So what will be our DIM? Your I is Y, and then your M here is X. Because the charge we are considering here is positive, yung Q which is on conductor X. So yung M natin is X at this point. Okay? So that your DKM will be DXX. Okay? Now, let's move on to the second conductor. And that conductor has a negative charge, which is negative Q. So, yung summation niya, hindi na plus, minus na. Okay? And then, same thing, ln of DIM. So, our I here is Y, and then M will become now Y. Okay? Because the charge now we are considering is on conductor Y. So, over DKM, it will be DXY. Okay? So, we'll just have to simplify this, no? Yun na yun. The next thing is to simplify this equation. So, okay, so, factoring out Q, okay, so Q over 2 pi E, or permittivity, and then ln of dyx dxx. So simply observing the natural logarithm properties here. So over dyy dxy. Okay, and then rearranging Q over 2 pi E ln of, so inarrange lang natin, inakyat yung dxy, and then over dyy dxx. Okay. Okay, further on, since our dxy and dyx here will simply be the same distance, okay, di naman nagbago, right? So, we'll just assume a common parameter for that, which is d, okay? Now, for our dxx, we'll rename it as Rx, no? So, kasi yung distance, self-distance, something like that, no? XX. So, will be Rx. Okay? That simply is the radius, no? And then, your dyy is Ry. Okay? So, plugging in those new elements, drx and ry, to our vxy here. Okay, so Q over 2 pi E, then ln of t squared. Okay, because dyx dxy is simply d, so d squared. and then Rx, Ry. Okay, so simplifying it, your ln d squared and Rx over Rx, Ry. Okay, so simplify lang muna natin, natural logarithm properties again. So LD squared minus ln Rx, Ry. Naging from quotient to to that config. And then yung 2 baba natin, 2 ln d yung power, di ba? So minus ln of Rx, Ry. And then, simplifying it, factor out natin yung 2. So, we have ln d and then minus 1/2. Okay? ln Rx, Ry. Okay? And then, will be 2 ln d. Okay? And then, gawin nating factor or power yung 1/2 for Rx, Ry. And then, so since meron na tayong minus here, may subtraction tayo. So, another property of the logarithm, magiging quotient. 2 ln of t over Rx, Ry square root. Alright? So, plug it, let us just plug in this dun sa general equation. Vxy is q over 2 pi e 2 ln of d over square root of Rx, Ry. So, again, we have these 2 and 2 cancelled out. So, finally, we have Vxy q over pi permittivity ln of t over the square root of Rx, Ry, and that is in volts. Okay? So, that is the voltage between these two conductors of a single phase line. Okay? So, to get the capacitance, diba, sabi natin kanina, capacitance is charge over voltage. So, it will be Q over the voltage Vxy. So, simplifying or plugging in Vxy here, Q over Vxy. So, we can have the capacitance between X and Y conductors, simply pi permittivity over ln of the quantity. Okay? And please take note that this is farad per meter. And yung capacitance natin XY, kasi di ba galing from the voltage XY, that is from line to line, one conductor to another. Okay? Now, the case if your Rx is simply Ry, so our conductors have the same diameters or radius. So, simply replace lang natin with R. Okay, kasi 1 R lang naman eh. So, we have pi E over or epsilon over ln D over R. Okay? There will be a case that the two-wire line will be supplied by transformer, which is grounded. Okay? Meron grounded center top. So, in that case, the voltage between each conductor to the ground, so parang line to neutral. It's not parang pala. It's line to neutral. No, the voltage from line to neutral, one conductor to the ground, okay, will simply be denoted as Vxn over or Vyn, no, will simply be the line voltage over 2, half of it. Okay? Now, if you plug this in, okay, dun sa capacitance, your capacitance will be, let's highlight this, no? Capacitance from line, either line, no? So, capacitance to neutral. Okay? Capacitance to neutral or line to neutral will be 2xy. Okay? So, this is not surprisingly new to us because, di ba, yung voltage is over 2, parang yung capacitance, why not over 2, di ba? No, it's not. Okay? So, if you only notice, no, if you also notice, consider this. Yeah. Okay, so this is the circuit representation of the XY capacitance, no? So if you have this in, if you have that in, okay, so yung CXN, this is your CXN, this is your, okay, from here to here, so CXN, and then your CYN here to there, okay? So try to get the total capacitance if, for example, the neutral line or the neutral point is removed, okay? What will happen to you, to us, is to arrive at this one, 2xy, okay? Remember, yung series of capacitance in series is treated as CXN times CXY over CYN over CXN plus CYN. Okay? So, when you simplify it, ito yung lalabas, 2CXY. So, you don't be surprised, no? Kung the capacitance to neutral will be twice the total or the line to line capacitance. No, hindi siya over 2. Okay? Well, because of this also, Vxy over 2, yun yung voltage over 2. No, yun yung half. Okay? So, capacitance to neutral or line to neutral will be 2 pi E over ln of T over R. Okay? So, there's a big difference, no? Your capacitance, or your line-to-line capacitance is pi E over ln of T over R. Okay? But if it's capacitance line to neutral, okay? So, line to neutral capacitance, it's 2 pi E over ln of T over R. Okay? So, please take note of that, no? Magkaiba kasi yung C, N, tsaka yung CXY. Okay?